Okay, so we are now live via YouTube. Okay. Magandang gabi sa inyong lahat. So, this is the Mozilla Philippines community. So, for tonight, we are hosting the Rust Meetup. And we had lined up two exciting talks from Alistair and Francis. So, just some reminders. So, please subscribe to the Mozilla Philippines YouTube channel. Just go to bit.ly/MozillaPH YouTube or just scan this QR code. Uh, Make sure that you hit the subscribe button. Okay, so we need your subscription. Okay, for us to change the URL. Okay, so thank you for those who are in this room joining us tonight. Though, yeah, we have Henry, we have who's this? JT and Romar, I think the other one. Okay, so yeah, if you have questions, you may post them on Twitter. Just tag at MozillaPH or use the hashtags MozillaPH and RusLangPH. Or if you're watching by the YouTube live stream, just leave a comment so we can ask the speakers later after their talk. So first up, so this will be our agenda for tonight. So checking in, and then we'll have Alice there to talk about async and await, and then we'll have a short Q&A, and then it will be followed by Francis Murillo. He'll be giving a talk on why a GC in Rust, and then followed by a Q&A, and then we'll have the closing, maybe a team photo or class photo afterwards. Okay. Okay. So Alistair, you ready?
Go, Alistair.
Alistair. Okay. So I'll be holding up my screen,
I
and
guess.
yeah. Okay.
All right. Good evening, everyone. I'm going to speak in straight English because I invited a few of my international colleagues to watch. I think they're just gonna. Some of them might visit the YouTube live stream.
Cool. Cool.
Um,
Thank you.
and tonight, how much time do I have, Bob? Sorry, I wasn't clear on
Uh,
that.
Basically, you have 20-25 minutes, pero yeah, okay lang tayo mag-overtime.
Oh, I thought it was gonna take 2 hours. So yeah, okay,
Oh, no
okay, fine.
problem. Okay lang.
I'll go ahead then. I will go ahead and power through this real quick. Um, So apologies, I wasn't able to come up with a set of slides in time, but I'm basically just going to be rehashing a series of articles that I wrote up on medium.com. If you want the URL, I'm going to paste it. I'm going to go ahead and paste it in the chat. Um, Otherwise, you can just Google for it. Demystifying closures, futures, and async await in Rust. I'm also gonna try and flash that on the second screen. By the way, yes, if you haven't noticed, we're using Firefox as our browser. Oops.
Thank you. Thank you.
Where did that go? Ah, here. Yeah. And the story behind this is real quick before I power through the slides and the demo. I wanted to write basically an API gateway in Rust, which I started last year before Async Await was GA. And so I used some of the libraries, and it was actually very painful in a sense. Um, when this year, when COVID struck, I decided to revisit what I wrote, and Async Await had gone GA was it November last year. So I decided to rewrite everything in Async Await, and as it is with Rust, I found that I had to go back all the way to the very beginning to so I could refresh my understanding of everything. We all know that Rust, as the saying goes, you have to run before you can walk. And I was telling another colleague, when you're trying to learn Rust, the initial learning curve is fine. It's relatively easy. It's very similar to other languages. And then within a day or two, you hit a vertical wall where you have so many concepts to pick up. Um, so I decided to go back all the way to the beginning and start documenting it as a series of articles. And I'm going to try and condense them now into the next I guess 15 minutes. I'm gonna set a timer so we don't go too much over time. All right. Um, real quick. What's this? Oh, that's not the one. Ah, um, fine. Slide. Go to the next slide. Okay. Real quick. I've been in this industry for quite a while. I've written code in many languages. Currently, I'm working with Ada support as a senior SRE. This is not working. Shows indicator there. Okay. Learned programming in BASIC, Pascal, C, object-oriented C, Pascal. Then picked up Java when it became popular. Picked up Ruby when it became popular. Then from Ruby, I made the jump to Elixir because it's, even though it's not popular, I think it's superior in every way. And so if you're just programming application level stuff like APIs, web apps, I think you can't go wrong with Elixir, or fine if you want Ruby on Rails. But and if you're writing other stuff, maybe, yeah, just Elixir. Never mind the other language that's compiled to binary. Um, but if you're looking for a lot more control over memory, want to squeeze the most performance, then if you're doing systems programming, that's why I decided to pick up Rust. Okay. And let's just go ahead and where is my terminal? Here we go. And yeah, where is my editor? Here we go. Okay, so I have here a typical cargo new. Oh, not this one. Oh yes, it is this one. But ignore the target because. And if we go to our editor, this is your basic main function, your basic template, cargo new template. I'm gonna change the font so it's a bit bigger for everyone. I hope that works. All right. So, first off, closures. Okay, but before we talk about closures, let's talk about blocks. So we all know what blocks are. Blocks are very familiar to everyone. In all languages have a block, and in most languages, a block is just an open curly brace, and that defines a block. Right. So in fact, this is the function block, and this is just an arbitrary block within the main function that we have right here. We run it. I don't know how to run it from the terminal directly, but we can do it from here, from VS Code directly. Cool. Okay. What else can we do with blocks? Well, what are blocks? Blocks are lexically scoped, so we can do stuff like let s equals world, right? And then how does this work again? I don't know. I'm just guessing here. Yeah, that works. Hey, I know Rust. Okay. And then the scope of this block includes the scope of the other block. So we could do something like let greeting equals hello, and then so do something like this, right? Okay. I'm making it bigger, and let's hide that. Okay, so. Oops, what's that? Unexpected. Right, sorry. Cargo dash x watch dash x run. Sorry, huh? Okay. So there's the trick. Cargo watch. Before we continue, I apologize. This is not my old computer. This is a new laptop. So here's a cool trick, so you don't have to use FS Watch. And but let's go ahead. And when we say lexically scoped, right, we can actually, that just means that we can have variables in two different blocks with the same name and um, different values. Okay, so this isn't just shadowing. This is really two different variables. Okay, because if we go outside of the block, for instance, let's try to do this, right? Then, in fact, at this point, we get an error because the VS Code Rust language integration knows that at this point, the variable s is out of scope. There is no variable s in the outermost block or in the scope of the function main. Right? But here, there is. So that's taking too long. Let's try terminal. And block waiting. Fine. This is taking forever. Let's not wait for that. Okay. Hello world, hello Mozilla. So why start with blocks? Because when we start doing closures, if you think about it, really, all it is a block, right? In a sense. So let's get rid of that. Closure is really just a block that people say it's an anonymous function, right? The difference between an ordinary block like this, for example, x plus y, that really doesn't work. Okay, well, we could do something like 1 plus 1. That kind of works, right? Print line. Will this work? No, that won't work. Will this work? Wow, that's interesting. Yes, it actually does work. So, but there's nothing great about this. So we can do stuff like x equals 1 and add x plus 1. That will work. Okay, and it should print 2. Okay, so real quick explanation. This is a block. And in Rust, just like in some other languages, if your last statement in a block does not have a semicolon, then the result of that statement becomes the value of the block. Okay, so we could do stuff like let y equals 2, and then x plus y, and that will print 3. Right. Now, from blocks to closures, the only difference, well, syntactically, is now we can add a parameter. For example, y. And in this case, we don't have to declare y, but now we can just call the closure like that. That's why we call it a anonymous function in a sense. Now we can do like add 3. And if we run that, then it becomes x. It's actually x plus 3, and then x is x right there. And right, or add 3. And awesome. So what? What do we gain, diba? Well, kanina, y was statically, the value of y was static to the block, right? In fact, the Rust compiler will probably optimize this at all this compile time. When we created a closure, we actually defined an anonymous function that we can call just like a regular function. Okay? But what's the difference? Why can't we just create another function? Call it add 2. add one, add one, and then y int I32, right? And then you just return y plus 1. Right. And you need a return type. And we could have used that just like add 1 to 2, and we'll just call it um, add 1 to 2. Oops. Oops. Okay. Yeah, sure. Okay. So far, nothing special. Why need closures if all they do is, create another function? The difference is, here, this is the magic. Just like when we saw with scopes, diba? But more than that, and I'll show it later. When we define a closure like this, what's in scope within the closure is also in scope. Parang in the outer scope is also in scope in the closure, and it's not just scope at compile time. Okay, one thing that we can do, for example, is we can pass closures around. Okay, so we don't just call them. We can actually pass them around. So let's create a new function. Well, Carlo install. While we're waiting. Okay. For example, fn receives closure. Okay. Closure. But now what do we do with our function, right? What's the type and what's the return type? Well, the return type could be nothing if we don't do anything with it, right? But let's call it evaluate closure. There. Okay, so in this case, let's just make it, so ano yung closure? Okay. I'll tell you right now without going into too much detail. If you want to write a function that receives a closure itself does not really have an opaque type. Well, it doesn't have a real type. A closure is an opaque thing. It's kind of hard to explain, but here, let me show okay, let's see if this works. Okay, here. Closure with a unique anonymous type that cannot be written out. Okay, so a closure is something, but we can't just pass it around. So to be able to pass it around, we need to use one of the fn traits. Okay, so in this case, the fn is a trait. Every closure implements at least, I think, the fn trait with the input type of the closure and the output type of the closure. Okay. And since we want to return that, okay, so what we can do is closure and then say call it with 10, 42. Yan. Oops, kulang. Fn cannot be at runtime. So the quick solution is whenever you see stuff like the size of something cannot be yan. Dying. Ano pala yan? Cannot be known at compilation time. If we try to compile this, there. The size for values of type fn I32 cannot be known at compilation time. So the quick solution whenever you have that happens is you box it. And box the whole thing. Okay. Next warning you get is traits without an explicit dyne or dynamic are deprecated. So we add that. And since it's not being used, we can now just go ahead and use that. Right. Print line or let result equals evaluate closure add. Okay. And print line result wait, because add takes only one value. So let's change it to take two values. Okay. Tanggalin ko na si add one. Lumang, all the old code. Oh, wait, tama naman. Hang on. Tama naman na, one value lang kanina. Box found closure. Okay. We need to, ito pala yun. So we followed everything and then still gonna get this error, okay? I'm gonna save you the trouble. The one way to do it is to use impl, but the other way to do it is the better way to do it is to just use, what's this? Generics. Ito yung sinasabi natin na you have to run before you can walk, where f is an fn of I32 that returns an I32. Okay. Evaluate closure f. Okay. Oh, okay. Cargo run. Ta-da! Okay, so let's run through that again. Tanggalin ko na si add 3, add 1. Let's get rid of all the fluff. Okay. We have a closure that accepts one argument. And it's called the closure because in this case, it closes over the values of the other argument. Of the scope of where the closure is. Why is this important? Because when we go to futures, this closure, we can still call it and it will still evaluate to 42 plus 1. So in this case, this is equivalent to add. Add 42. Add 42 is 1 plus 42. That's why when we print result is 43. Cool. So that's a closure. Yeah. We can also return a closure. So real quick, we can also return a closure. Right? Returns closure. And in this case, it's the function. Signature is easier. We can just do, if we're sure that it's always just one kind of function, then we can say impl fn I32, right? And then we don't even need a variable. Let's say x times 2, okay. Right? And so let cl equals closure, returns closure. Okay. And then we can do let's create another scope. Para lang, result equals evaluate closure. And yeah. Ta-da! I don't know why it's not formatting on save, but okay, fine, never mind. Okay. So to demonstrate, for example, that the closure really does a close over at runtime, not just parang lexical scope, we can change this. Hirap pala, wala tayong random number. But if this wasn't a static variable, a static integer, then the result of the closure when we evaluate it would still be whatever that variable was at runtime. Okay. Questions so far? Wala. Okay, I'm gonna skip the currying part. Let's go ahead to futures.
Sige, go ahead lang. Wala pang tanong din sa YouTube eh.
Oo nga eh. Sorry, I'm taking so much time. I promise to go faster now. Before we can go do any futures, it's important to note that Rust, because of its philosophy of zero cost abstractions, did not even ship with parang green threads or anything, just native threads. Okay, so it did not ship with any kind of asynchronous runtime. Okay. So by default, the de facto runtime that in the Rust community is Tokyo. So we have to add that to our cargo dependencies. Now might also want to go ahead and add the futures crate. The futures crate is not needed if you just want to program futures or async await, but it does provide a bunch of a bunch of helpful utility functions and structures that when working with futures. So now let's just, oops. Okay. Come on. Let's start fresh. Let's wait. Okay, nothing's happening. Cool. Okay. Okay. To start the Tokyo runtime, we can just go let rt equals Tokyo runtime new. Okay. This actually returns what's this? A result. So that's not useful, but if we're not concerned with error handling, we can just unwrap it. And then the easiest way to run code asynchronously, in a sense, or under the runtime, is just use rt enter. Okay. And what does rt enter take? It takes f, where f is an fn once. And fn once is just another trait, just like fn, meaning where f is a closure. And we don't actually need any parameters to the closure, but right. And, okay. And you can see here, it's running. Okay. Another way to use the runtime is to use rt spawn, okay, or Tokyo spawn. But let's just go Tokyo spawn, and here is where the futures crate becomes lazy, becomes useful. You can now do future lazy. Lazy is another function that takes an fn once, meaning it takes another closure. And say print line in future lazy. Okay. What is this? Unclosed delimiter. Okay. There. Okay. Okay. Wait. Needs that. Okay. The difference is future lazy requires a function that takes a closure that takes context. Okay, what's the context? That's the Tokyo runtime context. Since we don't need it for now, we're not concerned with it. We can just use the underscore placeholder, meaning this is the context, but we don't care about it. Right. So, and wait, what happened? In rt enter. Let's try that again. In future lazy. In rt enter. In rt enter, something's weird. Diba? What's happening here is, and we can even call it from here, Tokyo. If you're inside the runtime, if you know inside the runtime, you can do that. Tokyo spawn, spawn. And again, you can use future lazy. Just copy that. Future lazy context in future lazy in RT enter. Okay. But if we keep doing this, okay. So what's happening is, kanina, earlier we saw it actually ran, but now it's not quite running. So maybe let's just do, I'm gonna do this real quick. Sleep ms milliseconds. Let's try to sleep for 1 second just to see if this works. It's gonna say platform specific. Okay. Ta-da! Okay. Now everything's working, kinda. Whoops. So I want to call your attention to that. In the one run, RT enter, then lazy in enter, and then lazy. In the second run, it's RT enter, and then future lazy, the outermost, and then the inner future lazy. Okay. What's happening is we're now async. That's why if we take this out, the other two things are placed in the runtime, but they never get a chance to actually execute, because by the time RTN, this function call returns, and this is spawned, it's as if it's put in a thread, but Tokyo doesn't always use threads. Actually, in this case, it will use threads because we did this by default. And if you just create a default runtime, then it will use threads. So when you spawn it, it's as if this will be run asynchronously in a different thread. And so by the time the whole main function returns, none of the async closures get executed unless we force, let's say, a sleep of 200 milliseconds. Okay, let's try 100 milliseconds. Maybe even just 1 millisecond is enough for the runtime to. I know. Yeah, we don't even have to sleep here. Because why? When you do 2 RT enters, and there's another one which I'll show, you can go RT block on. Okay. Ooh, future though. Right. And that's there. Let's copy that. There. Let's rename this. This is RT lock on, and this is in RT spawn in Tokyo spawn in RT enter. Okay, but first we get an error. Cannot borrow RT as mutable as it's not declared as mutable. So once again, this is Rust. The reason that is because block on declares a mutable self, meaning block on can mutate the state of the runtime RT. So to fix that, we have to make this mutable. Watch run, and now it should work. Okay. Oops, but there we have it again. Okay. The only things that are guaranteed to run in this case are RT enter, the first one, and RT block on. Anything that is spawned, if you don't give it enough time, it's spawned asynchronously. So you're not sure if it will ever execute if you don't give it enough time to run. But RT enter and RT block on are guaranteed to execute to completion and sequentially. Okay. How do we know this? I'm gonna quickly do real quick. Okay. Let's add some logging. Okay. And then let's change, what's this? And I'm gonna do some here. Wait. I am going to create some magic real quick. First, I'm going to initialize the logging system. Just copying over some of my existing code. Cargo format. That. Okay. And instead of print line, let's replace all the print line commands with now. There. Okay. What did we just do? Oops. I added logging, a logging library, and I configured the logging library to just log to the console. But by default, that logging library will display not just the log priority, but something here in parentheses, which is actually the running thread. The other thing I did was in the runtime, if you actually want to see pala, beyond just the thread, we can actually see the threads starting. So let's change this to threaded scheduler, which is the default. Number of threads 4, but we add a callback on thread start, which accepts a closure, which is actually executed asynchronously as well. Okay. Meaning it's a future. And build and wrap. If we do that now, in RT enter on the main thread, thread number 3 starts. In RT block on the main thread, thread number 5 starts. Thread number 2 executes in Tokyo spawn. Thread number 3 executes in RT spawn. Thread number 4 on thread start. Oh, ito pala, we missed it. Thread 2, in fact, starts before we even get into RT enter because thread 2 is started here. Diba? RT enter goes here, and so on and so forth. Thread 3 starts. So this is peeking under the hood. If you really want to know what's happening, this is what you would do. Tokyo starts. Tokyo. This is what you would expect, diba? Tokyo in RT enter, and then you start a bunch of threads, and then block on and spawn, and everything runs, and everything is async, and so on and so forth. Questions?
There's one question in YouTube, pero it's not clear. And sabi niya lang is, this is Erwin Abelardo Pacheco. Run only once. I asked him if he can elaborate which one.
Where's the YouTube? Maybe we try to hop on the YouTube.
Or he's not answering. Konti lang naman yung viewers natin sa YouTube, mga 5,000. Yeah.
I'm not seeing
Here in the room, so we have we are 9 in the room. Do you have any questions for Alistair?
Where I'm almost done. It's actually I'm
Yep.
almost done.
Sige lang. Si Francis. Francis, you're still there?
Buhay pa naman.
Okay. Sige,
Sorry,
standby ka lang dyan.
I'm eating up your time. Okay,
Di, okay lang. We can
almost done.
go, yeah, we can go beyond 9 p.m.
Okay. So future
Live
lazy,
streaming with Alistair.
real quick. Future lazy is a helper function from the future state which returns a lazy struct. Now, if we followed that, what's a lazy struct? Ito, hindi siya makita rito. Lazy is just a struct that wraps in. Lazy here is just a struct that wraps an option f. And in this case, the future lazy returns as lazy struct that wraps an fn once, meaning a closure, right? But returns it as a future. How do we know it's a future? Because there, impl future for lazy. And so future is just another trait, just like fn1s closures are implement other traits. So we can in fact write our own function that tries to return a future. Okay, let's try to do that real quick. Returns future I32, and then future. To write a future trait out, you need to specify its output associated traits. In this case, output is I32. First we need to use std future. Okay. And then let's try this future ready na lang agad, ready 42. That doesn't work because it's gonna say traits without an implicit dyn cargo run. Yeah. Traits without an implicit dyn, blah 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 blah. I'm gonna make it smaller so we can see more. Okay. Deprecated, and return type cannot have unboxed there trait object. So okay. Fortunately, the Rust compiler is now very helpful. It's saying that for impl trait, that's what we can do. So we can actually do that. And just say impl future, but it says as all return paths of type implements future output, blah blah blah. Okay, we'll revisit that in a second. So now we can just go. Let's spawn that here. Ito na lang. Let's spawn returns future I32. And wait, we need to print something here. And then let's just return something. Let's just return a future that doesn't do anything. Future lazy. Debug in returns future. It's there. Closure that takes one argument. That's right. Okay, push it. And then we call returns future. And now that should work. In returns future. There. Yeah. So what just happened? We just wrote a function that returns a future. In this case, another lazy future that just prints out stuff to the console, logs that statement. And then we spawn that in our first RT-enter block. So it actually executed after RT spawn. I'm going to remove the on thread start so it doesn't, so there's less noise. Tokyo runtime, not builder new, it's just Tokyo runtime new unwrap. Okay. RT enter, block on spawn in returns future. So we know that it was lazily evaluated. Okay. So if you made it this far, congratulations, because if you want to do async await, the only thing to um, think about is this. All it is sugar. Okay. Let's try to write again our first async function. To write an async function or async block even, let's write our first async function. Um, you just write async fn async function. Right? And we can say, let's say it returns I32. Okay. And we'll just return, I don't know, 42. Great. We're doing async programming, yay! And to call it, let's try to call it here, async fn. Let result equals async fn. There. Okay, getting a warning. Function is never used, returns future, none of that. That's okay. Here, result, unused variable. Okay, fine. Let us print line or debug result and we get an error because future doesn't implement std fmt display. Huh? What? Async fn, we just saw it, async fn returns an I32, but when we assign it to an impl, when we assign it to a variable, it actually gets a type called core future. Okay. So we can try to await that, but now we run into another error, which is await can only run inside async functions and blocks. So, sige, I'm smart. Let's try to async that. Okay. Now we get another error, which is unexpected unit type because main, a mismatch type, because main returns a unit type, meaning if we desugar this, that's what main returns. And since this doesn't have a semicolon, it's saying that what we have is not unit type. So okay, let's try adding a semicolon like it says. Boom, semicolon. Okay, now we get another error. Unused core future that must be used. I think you already know what's happening. Futures do not do nothing unless you await or pull them. Okay, fine. Let's await it again. And we're back. It's going to be the same error. Okay. Await is only assigned functions and blocks. But we already saw the solution. Okay. Result is a future. Result is a future. Async fn returns a future. And then this is also a future. Okay. So in fact, we can do this. Async block equals sync. Okay. Now, because we have a runtime, we can do RT block on async block, or even RT block on result. Whoop. Use of moved value after kasi dito may result await. Right. No, that's not gonna wait. Yeah. That's not how we do it. RT block on async fn. And but now we can't await this. Now it's just a result. There. Ta-da!
Alice
Result
there.
is
Harry
yeah.
is going to ask something. Harry,
Sino?
are you there? Si Harry.
Yes, sir.
Yeah. Hi, Alistair. Tanong ko lang kasi I really haven't tried async yet. in Rust. Pero nag-search na ako ng mga libraries that I would na parang gagamitin, and I come up with Tokyo and Async STD. So parang I would just like to ask which of those libraries is better to use, or why should I choose Tokyo over Async STD? Something like that.
Okay, good question. Like I said, uh, no, okay. I think STD isn't quite a runtime, if you ask me. What it does is it provides a async version of the STD library.
Yung small,
I
I
think you
think
still
it's
need
async
runtime.
runtime.
Async runtime. There you go. Um, Well, to be honest, I wouldn't know why there's another one small. There's Rust async runtime. So, um, to be honest, I wouldn't know what the advantages or disadvantages of the other runtimes are. And the only reason why is because yun nga, Tokyo I think is the de facto runtime because like I said, when I started playing with Hyper, and if you want to write like web services in Rust using Actix or Rocket, all of those use Hyper under the hood, and Hyper uses Tokyo as the um, as the runtime. So parang siya talaga yung naging de facto standard runtime. But I'm pretty sure the other libraries will if they don't already support switching the runtimes. So it then becomes a question of which runtime has better features like performance, stability, I/O, network I/O, whatever, memory even. But as long as we're all using async, await, or futures traits, then they should be interchangeable, right? Does that answer the question? I mean,
Yeah,
roundabout
salamat.
saying,
Thanks.
goes both.
Thanks, Alistair.
Si Francis yata may dadagdag.
Yeah, async STD for I/O.
Yeah, because when async STD just provides wrappers, and you can't really control the runtime like Tokyo, which is I think more flexible in that regard. And I find Tokyo just easier to read, I guess.
So to wrap up, so guys, I went way over time. Returns an async function really can just be read as fn async fn foot, which returns an impl future, which its output is whatever the type. Async fn foot, disregard. Yeah. Okay, and then because we're returning a future, we can use the futures crate, right? Future ready, for example, is just these two, while they're very different, they compile to different bytecode. For all practical purposes, are the same or behave the same. These lines of code can be written like this. Okay, it disregars to that. Similarly, this async block can simply be thought of as let async block 2. Actually, bakit hindi tayo pwede mag-await? Kasi wait. Let's await. Instead of RT block on, let's await. Right, so that will show that it's really async block foot. Or foot closure, yeah, async block foot. Is really just a future lazy, okay, and then you can do this result. Yun lang. We cannot await result. What we can do is Tokyo, but spawn does not. Okay, Has to be within an RT enter, I guess. Basta. I forget the exact syntax, but if there was a way to like block on result, or actually this is not result, this is um, yeah, a AFN, just call it that, AFN. Right? Yeah, if there was a way to do um, future lazy, I'm not sure if you can do this, because then that means the runtime becomes reentrant. Uh, we'll see.
Alistair, I think your screen froze or it's on the other side of your screen. We cannot see what you're typing.
What? What? Okay. Let me double check. Share my screen again. My screen too. And so this doesn't work. Can you see my screen now? Yeah.
There, yeah, okay.
So
So you
this
try
doesn't
to
work,
type,
but
yeah.
yeah. But I'm just showing na these parang if we look at this, let async block equals async block, blah blah blah, and then block on that async block to execute it. It's as if we had written it this way. Future lazy context. Maybe we can do that. Now, wala. Context that RT. Wala. Anyway, if this was possible, which is not, but the way to read this is an async block is really just a future lazy. Okay, so maybe let's not do debug. Let's just do a future lazy and then 42, for example, right? And then let us sync, okay? Debug sync block foot. Let's evaluate it using await. Yeah. Here. This will work. Okay. So to wrap up, let's go backwards. When you see an async block like this, then you can think of it as being written like this: async block foot, and then future lazy, which comes from the futures crate, which wraps a closure, and then whatever is there inside that closure, whatever code is executed asynchronously by the Tokyo runtime. Okay, that's why we can now await it, just like an async block. I mean, this one is a real async block. This is a future. So async blocks are just futures. Async functions, an async fn that returns a type, can be thought of easily as a normal function that returns a future of that same type. Then, because it's a function, we can now await the function, okay, or the result of that function. Actually, we could have done this. Async fn await. There. Yeah. And yeah, hindi pa din future lazy. Questions?
Okay, guys, sino pa may tanong? In YouTube, yeah, wala na. So sabi ni Erwin, yeah, it was clarified naman daw earlier.
So to recap, closures are just structs. They're untyped or opaque types that are structs that return. Parang they close. They're structs that contain the state of the closure at the time that it was created or called. Um, and a future is just another struct that wraps a closure, diba? That you need a runtime to execute, and async await can now just be thought of as sugar that that where async just becomes a future and await is just the equivalent of RT block on. So pwede rin palang ganito. RT block on, async block foot. Yeah, we saw that. Right? So we can do this. So we really know that it's async. Here. Hindi pala pwede. Sorry, yun na naman. So that's it for my long overtime talk. Thank you very much.
Okay lang. O there, wala na kayong tanong kay Alice there. Checking YouTube and Twitter. Wala naman. Okay, dito, inside the room. Any more questions for Alice there? Okay, so Francis, are you ready? Alice there, maraming salamat. Thank you for
Thank
sharing
you.
that awesome
I'll still be here
presentation.
for questions.
Yep.
I can answer questions in chat or.
Okay, there. Francis, the virtual stage is yours.
Uh, okay, just like that. Okay. So, just want to know how many people here are comfortable with unsafe Rust in particular. Just gonna try to share my screen.
Okay, sige. Aha.
All right. Can you see my screen?
There, yeah. Yeah, okay na. Yep.
Okay. Just gonna move it back and forth just to check you can see it.
Yep, it's projecting.
Okay.
Okay naman, Francis.
Nice.
Yep.
Okay. So before I actually start, I guess I just want to say that and I'm a bit of a frustrated C programmer. So I started my career as a Java programmer, and I really had the hate for C back then. But over the years, I realized that maybe I was mistaken, or rather, I feel like I was left out in a certain sense. And I guess Rust is good ga- uh, a good modern language for me to actually go back to those roots. And I think it's really a good language. So that's why I'm here making a presentation. I guess that's just my intro there.
Yeah. Francis, medyo cutting out ka lang ah.
So yeah,
Medyo
you
cutting
guys
out
good?
ka.
Is it my internet? I think. Hello. Okay, so like with Alistair, I had prepared like an 40-minute presentation, quote and unquote, but I realized on like 2 days ago that had to go under 20. So yeah, I had to cut a lot of things out, but I hope you can still follow.
Sige, okay lang kahit hanggang 30.
So I guess so hopefully I can, with a little bit of leeway, I'll just talk a bit slower. So because I timed my talking fast, so hopefully I can now speak slower for this one. Okay, so let's just get to it. Uh, okay. Hi. Wait. There we go. So I'm gonna start with that. A garbage collector in Rust. Um, it sounds like a contradiction to Rust having a core feature of actually not having a garbage collector. But I do want to show you that Rust might need some help sometimes. It's not. Darn it. Sorry, let me just check. Okay. So for this talk, let's try to build a concurrent queue. So let's start by defining a simple trait that simply requires a push and pop. Just notice though that this trait does not require mutable references. The idea is that you can just plug it into a table a thread safe RC, and you can just use it willy nilly. Okay, mutex. Then you're actually in the right spot. Rust already provides an, what do you call this, vec deck on top of the normal vec, which is an double-ended queue, and we can quickly wrap that up into a mutex and get a concurrent queue. So in this snippet, I define a locking queue, which just wraps the vec deck with the mutex, concurrent scouts honor. Then I just create a standard, what do you call this, constructor. Then I just do the normal motions for a mutex, and then I create the same thing for pop. Simple so far, right? But as we know that mutexes or locks may not be the most efficient as other threads are blocked while waiting for it to be released. Perhaps we can do better. And by the way, this image is from HTTP cats. Just never mind. So the easiest queue to get
Francis.
by the way, I can see the chat screen. So if there are
Yeah,
any questions,
we're
read
only
it.
seeing the first slide.
Not is it the same thing again?
You're
All
still
right,
on the
all
first
right.
slide.
Can you, I'm gonna stop. Oh my sweet bejeez. Okay, I guess I'm just gonna open my editor for a while. Uh, yeah, I can see the screen while I do it, so do just notify me. I did test this out a little while ago. I'm just going. Can you see the current slide?
It's still the title slide.
Huh? Oh, okay. I'm just gonna close it again. I'm going to open another Chrome browser, Chrome tab. Seriously, I
Should
tested it
using
a while ago. It
Firefox
works.
kasi.
Yeah. Don't use IE.
Fine, fine. I wish Chrome you. Okay, just bear the gods of Mozilla. It's just that Chromium is just easier to install. Sorry. Anyway, I'm just gonna look for the presentation. Open, get the URL. Use the holy Firefox right here. Paste. Does Jitsi have a better support in Firefox?
Alistair, we
Okay.
can still see your screen.
Uh, okay. Can you see it? The Firefox window.
Now, yeah. Can you move on to the next slide?
Oh my god.
Uh, Hold on. You're still on the first slide.
Oh my gosh. I I just checked the application instead.
Sure, sure.
This happened a lot. Why does this keep happening? Excuse technical. Okay, still on the first slide.
Yep, first slide.
I'm just
Sige,
gonna try to
sige,
disconnect.
okay. So while we are waiting for Francis to be back, okay. So again, for those who just joined us, so this is the Mozilla Philippines Rust Meetup for this month. Uh, Let me see. Okay, so there. So we had Alistair earlier. So he talked about async and await in Rust. Okay. If you have questions, feel free to leave comments in the YouTube channel. Tweet us via MozillaPH. Yeah, Alistair is still online. Okay, so I'll be holding off my screen. Maybe it's a screen resolution or dual screen setup thing. For those who just tuned in, we are currently live in YouTube. Just search for Mozilla PH.
There.
Can you guys see it now? Okay, I guess I'll just continue on at least here.
Sige, go ahead.
So you can see the cute cat, right?
Mutex, yeah.
So anyway, I guess I'll just no locks. I'm at the no locks screen.
What we can see is still Mutex.
Huh. Okay. So something's wrong with Reveal.js, I guess. I'm gonna just refresh, I guess. I really don't know. Yeah. I'm gonna close it. Then I'm gonna open it again.
Are you sharing screen or sharing window?
Window at the moment. Then I'll disengage. Go back to it. Can you see it again? Then I'm gonna speed it up here.
Okay, so we can see your.
Can you see it moving?
Mutex pa rin.
We can see Mutex.
So there's a bug where if I use highlight.js, it stops showing. Is this what I'm getting right now? Okay. So you can see no locks.
Or are you
I guess
projecting
I'm going
your
to
window or the entire screen?
just the window.
Okay. Maybe you can try projecting the entire screen if you like.
Yeah, just try the screen.
Okay. Okay. I guess just gonna let me open my handy dandy notes. So since I'm gonna do it this way, please bear with me. Right. So attempting to share the screen again. So can you see the screen or no
No, not
locks?
yet.
Still Mutex.
Still the same, Mutex.
Okay. Okay. I'm just gonna do it one more log out. If I can, I'm just gonna share the whole effing screen.
Yeah, just share the whole screen. Sige, while we wait for him, kamusta kayo dyan? Sa kanilalagyan nyo ngayon? Buhay pa? For people who are here in the room, yeah, feel free to unmute yourself if you want to show your faces. No problem. Tay-tay lang naman eh. Huwag yung isipin naka-live stream.
Bob, next time, padala ka ng beer.
Okay, gonna share my
Yeah, sure. Next time.
okay, sharing entire screen. And okay, Okay, then I'm going back. There's a bug in the mutex.
There,
Yeah,
no
no
laps.
locks. Yeah, we can see it now.
Yay!
This one we can see now.
Why? I need to restore.
Hello? Choppy, choppy.
Guys?
Yeah, oh, there, go. Sige, go ahead, Francis.
Okay, duly noted that I'm not going to use review. Just you're gonna see my yes. Hello.
Which one? You're cutting out.
Maybe we can do better with so opening next slide. The easiest what do you call this? My internet connection is crap right now. Hello. Hello. Hello.
Hello, hello. You're cutting out. Your connection
How
is
do we
yellow.
reduce resolution?
No, no. On the window of Jitsi, you can go to the triple dot and then yeah, on the settings, try to lower down the resolution or manage video quality.
I hate my life.
No, it's okay.
Okay, I set it to low bandwidth.
Okay. Yeah, sige.
Okay. It's now on low
Yeah,
bandwidth.
sige. Mag-okay na yan.
But I'm fine. Can you just see this? At least, does it have enough resolution?
Sige lang. You're projecting na ba? We cannot see anything yet.
So, so we're on the Michael Scott Q
No,
page
I
or
cannot see
slide.
that. Maybe. Okay.
So anyway,
You're not sharing your screen.
so the easiest lock-free queue to implement is essentially it's just huh?
We cannot see you.
I'm sharing my whole screen.
We cannot see your
Ah,
screen naman.
wow. I'm gonna.
Okay, technical difficulties. Imagine if this will happen if you have an online class. No? Where is he?
Wait,
Oh, there. Go.
okay. Okay. Low video quality. G.
Yeah, we can see your entire screen.
Okay.
There.
You can see the Michael Scott Q on page.
Yes, yes. Go ahead. Okay na.
I'm gonna move back and forth
Sige
just a
lang.
bit. Okay, so I guess so the Michael Scott queue is essentially just a linked list with an entail is never null. To make it concurrent though, I use a compare and swap strategy. But this is a live stream, so I can't really ask. I guess. So questions, do just no, raise it. So fundamentally, compare and swap is just a synchronization tactic to safely change variable. You get a reference. It's pretty simple and quick. CPU may, in between the comparison, wake another thread that changes the value. Then software level, we need to do it at a more the hardware.
Hello, Francis. Sorry to.
So
Sorry. Hello.
Rust
Hello, Francis.
Rust offers atomic use size, and in particular, which is just technically, yes. Yes. Bye, Abby.
Hello, Francis. Hello there.
Hello?
Hello.
Ting
Go
ting.
go go
Hello?
ahead.
Yes.
Sige, we cannot understand you earlier.
Bandwidth. Can hear me right? I guess I'll go back. Stop hearing me. I don't know when my back blame PLDT for everything. I'm gonna retry at compare and swap is a synchronization tactile. You get a reference beforehand, then it's pretty simple in principle, but an assignment statement. Pause the current statements. We need something. So anyway, Rust provides concurrent primitives from the atomic module, such as the atomic bool, atomic hue size, and in particular, which is basically a thread saving no.
Hello.
I hate my life.
I'm not sure. How about the others? I did not understood anything. How about-
Internet still alive.
we can see your screen, but yeah, your audio is
Hello.
hello. Uh, yes. Okay.
Yes.
The screen is okay, but the audio is coming in. Yeah, choppy.
Can you? I think my net's going to be. My micro. Let me try again my microphone from my headset. Maybe it will come back to life. Hello. Yeah, it doesn't work. So I can actually mention anything good if I can do it. Let's. Okay, we're gonna go low. I don't think this would work. How low can I go? I guess Um, I see a question from Harry, but I don't know if I can be heard though.
Yeah, you're coming in okay naman
Yes, I
now.
can hear you, Francis.
Okay, so if I can get my message across, we're not really implementing a garbage collector in Rust. That's a complicated topic, probably in and of itself. But the case here is that when you do concurrent programming, you will come into trouble with you will come into trouble with how to drop variables, which will cause data errors. So at some point, Rust will need to defer to an library or module to handle the implementing a garbage collector per se. It's more of letting one side letting Rust be managed on one part of a program. Like in what I'm doing for today is when I implement a queue, I'll actually fail in doing so without using a memory management technique. Did that come across right, Harry?
Yeah, yeah, sure. Thanks,
I
Francis.
think or so I guess I'll just proceed. Maybe the gods of RNG are on my side now. Right? Just so sorry, guys. This just hurts my
Oh, it's
soul.
okay.
Okay. Okay. So I'll just proceed. I guess maybe nighttime people start sleeping. So just continue with the presentation. What we're going to use in particular for this concurrent queue is the atomic pointer. Specifically, we need the compare and swap capabilities that the library offers, and that it also works at the hardware CPU level, which guarantees a level of thread safety. When, for example, in this snippet below, where I try to change the next pointer of a node. So in here, I create a node with a null next pointer. Then I create the new node first. Then I start with the compare and swap strategy by loading a pointer via load method, which takes an atomic ordering. Then I use the compare and swap method of the pointer, which takes the old pointer, the new pointer, and an atomic ordering. If it returns the old pointer, the swap succeeds. If it fails, we just keep trying over and over again. That is the basic strategy of the Michael Scott queue.
Sorry, Francis.
Did that come
Excuse
across
me,
right?
Francis. Yeah,
Yes.
are you projecting
Yes.
something? We can see only your
Oh,
just display settings.
uh, oh my gosh! So it broke. It's broken again.
No problem. Just yeah, there. Try to reconnect your screen.
Okay. There. Here. Can you see, guys?
Yeah, there. Atomic TTR.
All right. I'm just gonna keep trying again, but yeah, so I've just mentioned atomic order. It's a very complex topic for me to just explain on the. Basically, it's just an so that threads can actually provide some level of data guarantees. The levels presented below are presented here are from the top the fastest. So for this talk, it's not really exist, and I just defaulted to sequence. It's the slowest, but it makes sure that follow a sort of causality. Can you hear me, guys, or still no? So I don't want. Maybe I should just record myself. Hello, guys.
Hello. Yeah, yeah.
So
Hello.
I guess myself. I feel like I'm fighting one of the
Okay.
problems of a distributed system. Yeah. So I guess I'll just record myself because I this is just and I can get a good RNG. Yeah, I will slides to GitHub and to get it all working together. Oh, yeah. Oh, so you want me to
Yeah.
upload
So
it
that
now?
yeah,
Oh, okay.
I can share my screen and then you can talk. Yeah.
Right. If you have time, I guess. I hope you can see my screen though. Might have to disengage that. Wait. So I'm going to wait. Can you go to my wait? I'm just gonna get the GitHub page. Shoot. Linux. Just trying to upload now. Thinking of a fast way. Yeah. Okay. I'm logged on in a different. Uh
Yeah. We can have a voice activated slide.
Thank you for your services. Okay, like if this ever happens, I just pre-record next time because yeah, this is not this is just in a,
But you're on 4G or 3G or wired?
wired.
Wired. Okay. Yeah. Let me know if you have the slides online so that yeah I can share it on my screen.
Here wait. Oh, I got the wrong origin branch. Git merge. Name this.
Okay, guys. So while we are waiting for Francis to upload his slide deck, nag-dinner na ba kayo?
Oh,
So who do we have here? So we have Alistair, we have Harry, Kirk John is here, Mikong is here, Francis, and I'm not sure who's fellow Jitsi user here. There's one who doesn't have a name. Thank you, Mikong. See you online next time.
okay. I'm just pushing to GitHub.
Okay.
Even this takes too long. Wow. Oh well.
And those documenters should be active in the group. There are many.
Well, I think I'm uploading MBs of data. I think.
Come again?
Holy crud. Hopefully, I'm not uploading. Oh yeah, MBs of data. Okay, looks like they're still small. Okay. Still waiting for the git pack to actually execute. I guess I'm just gonna wait. So I guess I'm curious if anybody did use unsafe or is comfortable with unsafe. I guess while we're waiting, I feel like it's not explored as much as I think. But then again, who wants to explore unsafe Rust?
I don't want to use unsafe.
Yeah, like whenever I try to use unsafe. Oh, whenever I try to use unsafe, I feel like I should be trying to find a way to use safe Rust.
For
Like
me,
I'm always at that pinnacle. Like,
for
come
me,
on.
unsafe
Go ahead.
should be parang reserved for platform specific stuff. So if you want to write a library that will work on Linux and Mac and Windows and Raspberry Pi, parang that's the time when you would write unsafe blocks based on the environment. Other than that, if you're using unsafe, I think you're doing it wrong.
Yeah, I feel like every time there's like that voice in the back of my head saying maybe you just need to try harder or look for some sort of a holy pattern to use on your problem.
Diba? Or write a library. If you have legitimate reasons for using unsafe, then write a library to abstract that all out so that everyone else doesn't have to use unsafe.
Yeah, true that. Have you tried writing just a normal queue without with just RC and ref cell? It's still uploading, by the way, so I'm just making small talk.
How much time do you need?
I have no idea. I'm just looking at an updated local branch, and then it hasn't. The git pack isn't done yet. I keep hitting the refresh button. Oh, oh, oh! Good timing. Can you try this? I put it in the chat.
That is a possibility.
All you have to do is just load the what do you call this, the presentation.html file.
Yeah, it's a 404.
Sometimes they have anxiety. So
Oh, is it still private? All right, forgot about private repos in GitHub. Okay, make public.
I don't think everyone knows.
Okay, can you try again?
Or the pressure. The UI is
Hello? Am I dead again? Hello?
Hold on, let me check.
Okay.
I think she's
But yeah, going back to just unsafe. I wasn't. I am not able to find a way to actually write a queue without going yeah, just a standard queue without going unsafe because of the head and tail restriction. Even though if you're just doing it for not for a concurrent program, but just in general.
Asia.
I tried using RC and RefCell, but um, what I think I had a problem with actually trying to change the reference of the head and tail, not just simply requiring multiple references to a single node, the head or an tail.
Hindi kaya ng ARC?
Uh, I like me giving up means I tried so many things, even trying to go into the more obscure methods.
Because that would have been my question at the end of this. Why can't you use atomic or automated reference counting?
Yeah. Yeah, like I was gonna go into that. I was thinking of rather why would I use a garbage collector when I can just use reference counting with atomic RC, right?
Yeah.
As it stands, I have not been able to actually implement implement this queue using just atomic RC. If you could implement it, then I would really want to see the code because I think I was going to weird areas of Rust for Repstel. but yeah, I know that's a legitimate question, and I could not, for the life of me, find an answer.
Okay, so oh
So
yeah,
to say,
sorry, I was able to open it, but
but that would have been my first solution.
Francis, I was able to open it, but it's a blank page.
Oh, I
Yes.
same here.
It's a blank page.
I opened the presentation
What
HTML and it's a blank page.
for you?
Yeah.
Or okay, I'm gonna press W. Wait, that's um. I can see something, that's for sure. It's in. I'm in the master branch and present. What in God's name that I can? Can you show me your screen, sir?
Uh,
Good sir.
Ito.
Sige yan, okay.
Just
May,
just so I
maybe we
can
have the same
relieve
screen.
myself of stress.
It's basically a blank page with a title, a case
But,
for a GC and Rust.
but does it have like a console error or something?
None. But yeah, looking at the what's this? The presentation.org file has some stuff in it. Siguro yun na lang.
Yes.
Hold on. It's not a presentation, but yeah, it will make sense. However, uh,
Wow.
so this is how it looks like.
Rip.
Uh,
That. Wait.
no, that's from
Did
your
you
GitHub.
copy it? Did you clone it? Oh,
This is
it
your
won't
yeah.
work directly from GitHub.
Pero yeah, this one has more content.
You have to download it.
Come again?
Oh, you have to actually download it and open it in your local browser
Yes,
because
this
it's a
one.
reveal JS.
This one is yeah.
Oh,
This one is in my local.
huh. I mean, you download it and use the. It has this. It has like a file scheme. File colon slash 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 instead of file github.com.
Sorry, hold on.
Is there a better internet in the Philippines while we're, while we're talking about?
Siguro if we can use this one na lang so that we can proceed.
Uh, the one in the one in
Yeah.
that one.
Can you use this one?
Okay. You. There. The thing is, there just won't be like code highlighting. If
Oh
that's
yeah,
okay.
sige lang.
And there,
It's better.
all right. Okay. Just rip code highlighting. All right. I guess we'll just move on to the lockless queue section. I guess I'm gonna stop sharing or something.
This one?
Yes. Lockless
Okay.
queue.
Okay.
A bit more. There should be an image there.
Atomic PTR, sorry. This one?
One more down.
Lockless queue.
Oh yeah. So okay, I guess I'll just use your services there. Thank you.
Sure, go ahead. Yeah.
Right. Okay. So in so now that we have cast or compare and swap, we can just implement the Michael Scott queue, and I just followed the, what do you call this, the link there, and it should be an image of an algorithm, but yeah, rip that. So if you want to get into if you want a better explanation, just check out the link. Again, you don't since you can't really read the code, I'm just gonna go through it. So next slide is definition. So we're gonna begin by just defining we're just gonna define just a standard struct holding using these atomic pointers. Hopefully the definition seems reasonable at the moment. Next slide. Uh, so we're just going to implement the new constructor for this queue. So what I do here is I create hello. I create an empty node, and then I create an empty pointer. Then I use a weird convert it into a raw pointer so that the box won't be dropped by the end of the function, because there's a weird unsafe rule about dropping pointers and dropping what do you call this references. It's an unsafe trick. Hopefully you won't have to use this one. And then I just plug it inside the return of the function. So next slide. Thank you. So so there should be an image there about implement that should be a good what do you call this reference image, so you can understand what's going on. But basically we're just going, it's like a linked list, and we're just inserting an element into the tail. So next slide, next section, which is just push. So it's a pretty big function, and this is where code highlighting should actually support us. And now it's gone. Hello, sir.
Hello, yeah, go. Hello, hello.
It's a bit dark on your screen. It's a bit shady on your screen.
Hello,
Hello?
hello, hello.
Hello?
Yes, go ahead.
Your screen is a bit choppy, or
Not
is it
sure.
just me?
Maybe it's you.
Yes, it is choppy.
The screen is choppy.
Yeah.
Okay, hold on.
Rip. All right, yeah,
That's
that's
good.
good. Thank you, sir.
There.
Anyways, so it's a pretty big function, and I was supposed to use syntax highlighting to get you through it. So I'm just gonna hopefully just list the few aspects about it. Maybe you can just look at it in amazement while mention the points. So anyway, starting at the beginning, I create the new node before starting the compare and swap loop, and apply the same box new box into raw trick before going to the loop. Then the next still the same, meaning that no other thread is interfering. Then I check if the next pointer is null, meaning that we're in the tail, meaning we're safe. And then on after that, I try to swap now the next node to that node we just created. You can see there's a compare and swap takes the next pointer, node pointer, and the ordering, and you can same pointer. But if that works, we also try to change the tail pointer to the new node. So we're doing we're trying to point the what do you call this? Two pointers to that new node that we just created before the loop. And if whether or not that succeeds, we return. And then if any of the checks fail, we just keep trying again and again. So that's pretty much the basic strategy of the push. We now move to the pop method. If you have questions about this, yeah, it's pretty I guess what do you call this? Tough. So you don't really have to understand it. In this case, what we do instead is to point the head to the next node, and then take the value from it. So anyway, going through the function again. So same strategy. I load the head and the next pointer in preparation for the swap. I also load the tail pointer to check if the queue is empty. Then on the same tactic, I check if the head pointer is the same. If the head pointer was unchanged, then I check. Can you go down a bit on the screen? We're in the else branch.
Yeah,
Thank
just
you.
to take the, I think all the
So assuming we have something to remove or not, we're not on the like the head and tail are not pointing to the same node, meaning it's empty. So assuming we have something to remove, I load the next node. Then I attempt to compare and swap the head with head pointer to the next node. So if that succeeds, I take the value from the next from the that soon to be head. I drop the old head via box from raw. Then I return the value of the what I call this the new head, which is now none. So it should be like even state or like an basically the first node should always have none as their value. Go Alistair.
I pressed the raise hand button by mistake there. Go ahead.
Oh, okay. So that's the it's that's a general idea by the way with pop. So if you just follow the link, it should be it should be the equivalent. So can we go to the next slide? Sorry, next
five
page.
minutes now for BPE, beginning and end.
Yes,
Which
sir.
which
Good
one?
hunter. Memory
Memory.
check.
Memory?
Just the next slide,
Okay, here.
which is the memory check.
Yep, go.
Just a little bit, gracious. Oh, your screen is frozen, I think, or maybe I just have again bad connection.
Let me try this.
Yeah, I can still see the old. We're just gonna go into the more nitty gritty. Just the what do you call this? Checking if the binary works or the queue works.
Yeah. I don't think on a cluster group, whenever you members, right, then he or she would have no keys. So they have their own separate group.
No dice
So
or
Which
not
one?
yet.
so I have time.
I still is it on the memory check page?
If someone is on the cluster, give the user
Hold
no
on. What should be the content now?
Ah, yeah, that's right now. Yeah, I can see the slide now. Thank you. So in order to, so I'm gonna start again. So to check if the queue has no memory leaks, I created a small binary so I can run it under a memory check tool. So in this binary, I create what do you call this? I push some elements into our queue, and then I just pop until it has no more. The memory. Can't seem to see anything.
Hello, Francis?
Shaky cam. Yes.
Hello?
The screen is there we go. Can you move to the next page or just the next one is
Okay,
Valgrind.
go.
All right. So if you're using Rust, Valgrind is a good tool to check if Rust programs leak memory, since we are using so much unsafe. So using it on the binary tells us that it's clean. So we have quote unquote have a working queue, but maybe not yet. So on the next slide, It's a bit choppy though. I can see the screen. Or unless I'm just need to set it at a lower bandwidth.
Yeah, we're on the concurrency check.
Okay, so if you guys can see it, all right. So on the concurrency check slide, I create another binary to uh, I create a binary that in such a way that 4 threads will continually push and pop 100,000 times, and hopefully it will not crash. So on next page or next slide, which is Valgrind again, tell me if you just change. So I'll just pretend that it works on your end. So if you check the output, it would show you that there's a memory error of an invalid read size of 8, meaning we made some unsafe allocation or deallocation. So moving on, going for the investigating it on the next slide, the ABA problem. So just tell me when you're on the next slide, then I'll just pretend that you're there. You're there.
Yeah, there's a delay lang. Okay.
Okay, I can see it. Thanks. So what I demonstrated is the ABA problem for compare and swap strategies. In our case, it's about improperly dropping a node while another thread is using it. Looking back at the pop method, if one thread is about to drop the head node, which is on the comment thread one here, but if another thread uses it at the thread 2 line, it would cause an memory error, which is the problem we're seeing right there. So going to the next slide, memory management. Just tell me when you're there, and I'll just proceed.
Yeah. Sige.
All right. So apparently, the Michael Scott queue actually stipulates that it does not drop memory or drop nodes, but actually reuses it on a free allocation list. And if you don't have an allocation, if you don't have if you can't reuse the nodes, you're allowed to use a form of garbage collection to mitigate this error. So if you did try to implement the Michael Scott queue in another language, you wouldn't really have this problem because most of the time it's garbage collected and the problem just goes away. But I guess my point here is that for all the effort I put in just to implement that queue from what do you call this from that guide or link, vanilla Rust is not apparently good enough for this case. So again, so biting the bullet, what is our options for quote unquote garbage collection in Rust? So so I'm on the Epoch base now. So thank you. So I checked the Rust ecosystem for various memory management libraries and schemes, and only Crossbeam library is the only one that provides a documented Epoch based garbage collector, and that's a mouthful. And it's pretty arcane in a certain way. Anyway, next slide. So yeah, thank you. Garbage list. So explaining how Epoch-based reclamation works is technically unclear to me. My intuition is that deleted objects go into and that object will have like an counter incremented each cycle. After a certain number of cycles, it will be deleted. But the question is, for Epoch is how is the counter incremented and how are objects managed? So next slide is managed. Just ping me as usual.
Yeah, go ahead.
If it's there, okay. So to turn Rust into an own from an own type to an managed garbage collected when you can manage collected type, you can just wrap it in an owned or a thread safe atomic type, which pretty much just registers it to the garbage collector. So it looks pretty natural, especially how it has like an owned and atomic. It also has a shared type, which kind of corresponds to Rust what do you call this ownership model as well. So next slide. So pinning.
Yep, pinning.
Okay. So whenever you access managed data, you need a thread local guard that pins or protects access variables from being dropped while active. when the guard is dropped or unpinned, the object counters are possibly incremented and garbage collection is executed by that thread that dropped the guard. I confess I could be wrong here, and this is just possibly me pulling things out of my butt. But the documentation for Crossbeam Epoch is just as vague, and all I've done is research as much about the libraries I could to come up with how to use compare and swap in what do you call this in the library. So next slide, usage.
Yep.
Okay, thank you. So what we need actually is just really compare and swap. I could think that the garbage collector or epoch base is just a black box, assuming that properly. So in this snippet, for example, if I wanted to change an account balance, I would define the struct, say that it's atomic. Then I create like with the old strategy, I create a new account with the initial balance. I create a new account with the initial balance. Then I create the new balance via the own type. Then right before starting the compare and swap system, I get a guard or a thread guard via the epoch pin. Then once what do you call this? Once I need to get I need to get first again with the cast, I need to get the old reference. So I do it via debit that balance that load, which takes an memory ordering plus the what do you call this? The memory the thread guard that we receive from Epoch, and we'll get a shared reference to that garbage memory managed what do you call this? Memory managed pointer. Yeah, just excuse me on that. So either anyway, it's doing compare and swap is pretty much the same thing, and all I just added there is the guard at the end and converting the new balance into a shared reference. So it does function like an atomic pointer, but it does feel better, and it has less unsafe, which is really good once you start using atomic pointer. It's like so much unsafe, and it does feel like it matches Rust pretty well. So going to the next slide.
Go.
Okay, so with this new strategy, I went back to the queue and just changed everything from lockless, changed everything from atomic pointer to epoch based, and since it's pretty much the same, it's just really the same code but slightly different in that semantic. So in the next slide, drop fix.
Okay.
Okay, since can you go to the line where there is guard that defer destroy near the unsafe? There's an unsafe block with the guard that defer destroy.
Yep. Yep.
If you're there, that is the secret sauce of this. By converting everything to a managed memory managed queue, this single line fixes the issue with our concurrency from our previous version of the queue. What this does basically is tells the garbage collector not to drop this what do you call this node while other threads are accessing it. Can you go up to what do you call this near the loop, the for the while loop? Just the loop. While the guard basically exists, everything that the thread has, everything that the loop has, the function has access is protected from being dropped. Now, if you go back to the issue, even if the wrong what do you call this wrong node is loaded via the next shared pointer, thanks to the CAS algorithm or the algorithm itself, it should prevent it, even though it's not it's what do you call this un misaligned, or sorry, it's not misaligned, it's an invalid, it's not basically it's no longer a part of the queue. It should just fail the if check and will safely handle that issue. So yeah, I guess I just want to say that one line is enough to fix our issue. And then going to the next node, next what do you call this slide?
Yep.
So to put our theory some benchmarking and on some concurrent queues, I chose Criterion for the what do you call this? I choose Criterion over the default cargo bench as it is more flexible and overall has better reporting, fairly easy to set up. And generally, we're checking out find the image attached to it. There should be like an is there an image there afterwards in the next slide called report? I think that's
Yeah.
like I really took my time on making this graph. Can you see the graph?
No.
Can you just go to GitHub and just go to the images folder
Hold on.
and just yeah, like it took me some time to actually get this graph, like running cargo bench a few times.
Which one here?
I think wait, oh my gosh, it's checking benchmark
Okay.
SVG.
There you go.
So you guys can see it. Okay, so so once you got Criterion running, this it gives us a nice HTML report. So this graph represents how long on average a concurrent queue executes 1 million combined push and pop operations spread over a variable number of threads, or which is the x-axis. So taking a closer X plus vecdeck queue, and should have been expected to perform the worst, which is the yellow line. However, I added a queue where the head and tail are locked separately, which is I think the green line, which strangely performs worse than locking the whole collection. So what this tells us is that it's not just merely lock contention that we're trying to what do you call this, tweak. We're also trying to be efficient in the allocation department, so it's just not all locks make things slow. It's also like there are a lot of things that go into this, but that's just to add flavor. And the blue despite that, the blue line, which is our garbage collected queue, which we just implemented, performs better in most cases, like around 4 threads. It kind of, at least it beats the mutex plus vecdeck. Plus it's plus it doesn't leak memory. But anyway, so so just to set expectations, why not just get a concurrent queue, like, right? And I did. So I got Crossbeam's seg queue, which is far superior from the Michael Scott queue. And if you look at the red line, it just speaks for itself. No contest. Just it just wins. So lesson there is no need to write your own, what do you call this? No, your own concurrent collection, right? So going back to the what do you call this? Report to the slide. Yeah, just
Which
again tell
one?
me if you're
The
there.
slide deck?
The slide. Yeah, we're at the zero cost abstractions.
Okay.
So like as Alistair has mentioned, like Rust has a philosophy of zero cost abstractions. What you don't use, you don't pay, or basically everything is more or less a trade-off. So this whole presentation was just to show that Rust can still have a garbage collector and still feel like Rust. If you think of garbage collector as a library or trade-off, then I think that's not in competition with or contradiction to but hopefully you won't actually have to implement your own concurrent collection to actually need a garbage collector though. So next slide is one more. So this talk is inspired by chapter 7 of the hands-on concurrency with Rust book, and it's a bit dated, but it works majority of the time. And I guess just thanks for sticking. I can show my images. Thank you. But do you guys have questions aside from, or did I convince you, or just made you more jaded?
Okay, guys, if you have questions for Francis, I'm just checking on YouTube if someone actually asked. None so far. On Twitter, none yet. How about for those who are inside the room, who are still in the room?
It yeah, I'm just gonna or
Yeah, go ahead, go
please.
ahead.
Yeah, like anyway, I'm just going to mention that garbage collection in Rust anyway is not good. It's not so rich yet, so I hopefully you won't have to delve into it. I just want you to just realize that it's not a like no runtime and no garbage collection. I mean, Rust can have them, but it's going to be like in its Rust way, not just like an all-encompassing thing like what we usually have. And it's pretty impressive, rather, that you can have a garbage collector in Rust at your disposal, like Tokyo Runtime, which you can set up at your will. And I really like that. Yeah, I guess if nobody has any questions, anyway, thanks for staying. This I'm gonna record next time.
No problem, yeah. Or just switch to another ISP.
Is there another ISP that works?
That's a perennial problem in the Philippines. So yeah, it's a Filipino thing. Okay,
Just
yeah, would you like to add more?
no, sorry.
How on? I just there. Are you saying something?
No, 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 I'm good.
Okay, so there. If you don't have questions, going once, people inside the Jitsu room. Next time we'll try a different platform. So what we're doing is we try to rotate different platforms except Zoom. Okay,
Nope soon.
no Zoom. No, no, no. No, maybe what? Maybe one of these days. Yeah, but yeah, for my own, I use 8x8. If you had heard of 8x8, so it uses the same technology as with Jitsi. It has an app. Yeah. Okay. Buti na lang yung chat hindi kasama sa live stream. Okay. Or yeah, maybe we can use Google Meet. Okay, next time. So yun.
Are we going to be
Come
banned
again?
if we talk about that? Like if that's your client, are we going to be noticed?
Yeah. So yun.
Oh, good, good.
Okay. So yun. Yeah, parang the perennial problem is I've been attending events lately online, and yeah, one of the things that I've noticed is when the organizers will try to mute everyone in Zoom and basically disable some of the functions for the attendees, and then the presenter will just ask, "Can you see my screen?" And then nobody's able to answer except that when someone is monitoring the chat.
Okay.
Okay, so there. So
Yeah.
yeah, to close. Okay, so again, so thank you to Alistair and thank you to Francis for sharing their knowledge and thought about Rust.
No, thank
Okay.
you, sir.
Meron kaming what do you call this? Meron kaming certificate pero we will just send it to you via email, virtual, Hindi,
Digital
well,
certificate.
yeah, yeah. So we have a certificate for you guys. We'll just email it to you, and yeah, I'll get in touch with you. Tapos to the rest, the people who attended here, so we still have six people. Kanina we went to as high as I think 9 or 10 people inside the room. Maraming salamat for staying. Yeah, in YouTube, yeah. So this is recorded in YouTube. So you are now in the history books of YouTube. So people, some,
So I'm sad that I can show this to my
yeah,
employer
yeah, sure.
because of the technical issues.
Yeah, it's part of any live event. So yeah, it's okay naman. Okay lang 'yan. Sabi nga ano yan technical speaking, palakasan ng sikmura yan. So, congratulations. Okay, there. So, maraming salamat sa ating lahat. Teka, I'm going back. If you guys are still here, if you can turn on your camera. Teka, I'll be putting up my okay, share screen para we can have a group photo. Sino pa ibang na dito? Kirk, are you Kevin, sorry. Okay. Kay lang kasi nakita ko eh. Talaya, there. Ako nawala. There. Okay. Kevin, are you there? Okay. 3, 2, 1. One more. Okay. Let's have a photo. 3, 2, 1. Okay, there. Maraming salamat sa inyong lahat. See you next time. Eto, medyo since we are all locked at home. So yeah, mas madali na ako maka-invite ng ibang speakers. Wala, hindi na physical eh. So kailangan lang connection. So yeah, meron ako isang speaker na kinakausap kaya lang iba yung time zone. So let's see what we can do. Otherwise, we'll move the next meetup to something like 1 a.m. Manila time. No, no. Okay? So there, maraming salamat. Ingat kayong lahat. Until next time. Bye-bye.
Thank you.
Thanks.